Hello friends, this video on relations and functions part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. L will be the set of all parallel lines in a plane and R be the relation on L defined as L1, L2 where L1 is perpendicular to L2. Now the question is, we have, let's suppose, so many lines in the plane. Okay, so many lines in the plane we have. I'll mark the line as 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the question is, we have to show that this relation where I'm saying that L1 is perpendicular to L2 is symmetric but not reflexive, not transitive. So if you see, there are 9 lines. The relation is L1 is perpendicular to L2. If you see here, you can see that line 4 is perpendicular to 3. So 4, 3 is the relation, correct? And similarly 3 is also perpendicular to 4, so 3, 4 is the relation. 6 and 7 both are perpendicular to 9, so you can see that 6, 9, 7, 9, 9, 6 and 9, 7. They are also perpendicular. So these are the perpendicular lines we have, because this line is not perpendicular, or this is also perpendicular, 5, 6 and 7. So we'll say 5 is perpendicular to 6, 5 is perpendicular to 7. Similarly, 6 is perpendicular to 5 and 6 is perpendicular, 7 is perpendicular to 5. So these many perpendicular line pairs we have got. Correct? See, the set of lines we have, this is the relation we got, because this is the set 1 to 9. Now from this, if you get, this is, let's suppose A, if you find A cross A, you'll get so many numbers, right? 1, 1, 1, 2, 1, 3, dot, dot, dot. Similarly 9, 1, 9, 2, 9, 3, dot, dot. So out of these, the one which follows this criteria is that L1 is perpendicular to L2 is these values. Correct? This is what we have got, because you see this line is not perpendicular actually. Let's assume, we are assuming that 5 is perpendicular to 6, 3 is perpendicular to 4, 6 is to 9, 7 is to 9. These are pairs we have. Now the first thing we have to show that it is symmetric. For symmetric, what I told, flip will happen. That means if A and B exist, then B and A also should exist. Correct? So if you see 6, 5, there has to be 5, 6. This is there, one pair done. You see 4, 3, there has to be 3, 4. This pair is done. 6, 9, there has to be 9, 6. This pair done. 7, 9, 9, 7. This pair done. 5, 6, 5, 6 done. 5, 7, 7, 5. This pair. So if you see any number, A and B exist, B and A also exist. So that means it is symmetric. Correct? This part is. For reflexive, I told that all the elements with itself exist. That is 1, 1, 1, 2, sorry, 2, 2, 3, 3. Such kind of elements should exist till 9, 9. But if you see 1, 1 is not there, 2, 2 is not there, none of them is there. So it is not reflexive. For transitive, I told, if one A, B is there and B, C is there, then A, C also should be there. Let's take my example. For example, 6, 5 is there. Correct? 6, 5, and then let's take one more with starting with 5. This 6, 5, and let's take this 5, 6. 6, 5, 5, 6. If you pair this, what you get? You get 6, 6. But 6, 6 is not there in this. So this is not transitive. Correct. Also logically, also if you see, I'm talking about symmetric. If A is perpendicular to B, then B has to be perpendicular to A. So it is symmetric. A can never be perpendicular to A. So it is not reflexive. If A is perpendicular to B, B is perpendicular to C, then A will not be perpendicular to C. Actually, A will be parallel to C. Sorry, parallel is like this. Thus, logically also if you see, this is symmetric but not reflexive and transitive. Mathematically what we have done, we have found A cross A, and from this we found a subset using the relationship. The relationship was L1 is perpendicular to L2. So we got this subset, and this subset is nothing but my relation R. Now in this relation R, I observe that it is symmetric. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.